So let me explain what I did for the electrical here. Basically right here, coming from my house to the new construction, there's 3/0 copper, 2 hots, 1 neutral, and a 1/0 ground that I pulled from that main panel to go to that building's main panel, which is really a sub panel. So when I did that, I'm not going to pull this cover back off because I just went through the trouble of getting it back on. When I did that, I basically brought the wires in, cut them, brought the wires out, and I put in a 3 connector Polaris. So that way I could tap a third one on, ran another conduit under, and punched in that same size wire to here. So that size wire was for 100 amp service out there, and it was way overkill. But the reason that it was so big was because of voltage drop. So to get the 500-foot lengths, I had to oversize it quite a bit. I could have done 1/0, but I did 3/0, so that way I'm way under 3% voltage drop. I measured over there with all the loads on, and I'm like still 240. It's high. It's over 240 actually. It's 245. So I got really good current coming through here. But the thing is, because that's fused at the house as 100 amp, I couldn't tap into that directly unless I was going to have it continue to be the same size wire all the way down to the pump, which is insane because that's another 400 feet. And that wire over a year ago was over $5,000. So what I did was, with the 3-knuckle boom, pulled it over here into this panel. So this is basically another sub panel. So because this panel is rated for 100 amps, I'm good. It's all, it's legal to code, stuff like that. It's black wires. They're brought in and taped by color. So now this basically is an additional panel. And from there, I pulled this 50 amp right here, second one in, a 50 amp 240. So it's got 2 hots coming down, and the hots go into this and the ground. I didn't pull a neutral. There's no real need for me to pull a neutral down to the well. So basically I've got 2 big hots coming in, and a neutral that land back in this panel, and then a ground that lands in the panel on the bus bar, and then a ground coming off of the bus bar going down, and 2 hots coming off of that 240 50 amp coming down. So I did 3 total wires, and you can see when I was pulling the wire, I was just kind of trying to knock it out. While I was there, I figured I'd pop in this 20 amp, and I just put an outdoor weather rated GFI here. So if I need power, I got power. I have power fairly close by anyway, but just because I put that one in there, I actually have that outlet left over, or the GFI outlet left over. So those come down, and they run 400 feet to the well site, which I'm going to just zoom in right now. Right there, you can just barely tell. I'm going to try to get my finger in the page. It's going to be huge. So that right there is a disconnect. Boom. So my next stop is going to be down there. But 50 amps, I really only needed to pull. I could have done a number 10. I was going to do an 8. But because, again, the distance to be around 3% voltage drop or less at 50 amps, I pulled number 6. So I got 2 number 6, a black and a red number 6 all the way down, and a buried, filled-in conduit. You can just barely see here. So this conduit loops down and all along the road, and then a number 10 ground. So let me go down there. Alrighty. So here's the breakdown. Conduit comes right through here, all the way. We were just right up there at the tank. Boom. It brings in the number six hots. The ground is grounded to the bus right there. Again, I didn't put a neutral down here. If I wanted to have an outlet, or usable power for 110 or 120 or whatever, I would have needed to bring in neutral. So this, I won't put an outlet here, but it wasn't really that big of a thing to me because I have an outlet not all that far away. It wasn't worth having to add another wire. Although the pull was kind of a pain just because of the length. It's 1-inch conduit. It pulled the 6, 10, no problem. I really could have added another 6 and not had a hard time, except wire costs high right now. So for 500-foot spools, 6, 6, and 10 was like $1,000. And I do make the mistake of always pricing the wire without adding the conduit. So again, 400 feet of conduit, a sweep, that box, a sweep, this disconnect. You know, it was expensive. It was a couple $1,000 realistically to get wire down here. And then from there, so basically we've got the 240 coming in. This is off right now, and then 240 comes out. Matter of fact, in reality, it comes in on the bottom and goes to the top, and then it actually comes out the bottom and goes to the side. Now this is live. It's live coming in on the line side. It's dead going on the load side because the switch is off. So then it comes through this liquid tight with a coupler, or with a connector, I think they call it. And a connector, it comes in, and then right here, I've just got this cover set on, is the VFD, the variable frequency drive, that's going to do on-demand control of the pump. So this is going to have to be its own totally separate video, but basically you can see the hot and ground come in, and they just make the 240 volt connection. So the specs on this controller called for 50 amps specifically, and they can be a little sensitive to voltage drop, so that's why I did the 50 amp with number 6, because I want to make sure that I for sure get 240. I want to be under 3% voltage drop here, even at maximum load. So this, I mean, I can power up actually. You know, it'll do its startup sequence. Obviously it doesn't have everything connected because I still need to have the pump, the 3-phase pump, wired in. I don't have that pump. I have the motor, but it just does its self-check, and I'd imagine this is some error code, so I haven't read the manual on this, but I am set up. I got power on site. And then, you know, I guess, to be honest, that stuff wasn't super technical. It's a lot of work, but something that I wouldn't hire that out. That, well, I mean, I guess if you have no idea what to do, hire it out. But if you're pretty handy, most of the well people were kind of like wanted to give a price, not including getting the electrical. They want to just, you know, they basically want to just do the drop of the pump and the motor and the drop pipe and the well seal, and then just kind of stub it out and put a valve right there, and then, you know, maybe just slop the wires over. They might even want to hook it up to the VFD, but none of the, I talked to 3 different well people, and nobody really wanted to give a complete bid with all the electrical, I guess, because there's a lot of variables there. Here to here, not a lot of variables. Here to the main panel or wherever, a lot of variables, and they want to give a pretty basic price without coming and doing a whole lot of work to be able to give that price. So I'd imagine that's typical. And then, you know, this video is mainly about the electrical. So coming off of a VFD is going to be this pressure transducer, and that's going to communicate to the VFD what the pressure is, if it should speed the pump up, slow it down. The pad turned out sweet. It's just yesterday, but it's safe to walk on. It's been almost 24 hours, although I'm not going to try to get this big old tank up here. So from there, a minor note, I just went and bought all this brass. This is just sitting here. It's loose. Because what I decided to do was a little different than expected. I'm going to do 2-inch. I'm going to do 2-inch everything. 2-inch drop pipe, 2-inch brass, 2-inch shut-off valve, 2-inch check valves, 2-inch everything to that 2-inch main. So that way everything here is 2-inch, boom, to right there where it splits off 1.5 inches, 1.5 inches. And I did that looking at a lot of things. I could have moved the 35 to 45 gallons per minute through this tank tee that's 1.25 inches. This is the biggest tank tee I could get. but it would have had a really high velocity. I don't remember what the number was, like 15 feet per second or something. It was going to be a lot. And, you know, I was reading about for every foot per second that you add in velocity, it does create more load for the pump. So being that I'm trying to be really energy efficient, the main actual pump will pump up from here 2-inch to the main. Now, when that pump is not, you know, if the pump is off and I have a big pressure tank here, that pressure tank is only going to push through the 1.25 inch, but the pressure tank would mostly be used if we flush a toilet, turn on a sink, etc. And that's not going to flow a lot of gallons per minute. So I'll be 1.25 inch teed into the pressure tank. The pressure tank only has an 1.25 inch connection anyway. So I think that this is going to be my setup. I'll do my own total video on the actual plumbing, but just kind of rough it in and looking at some stuff. I did some measurements and went to the commercial plumbing place. This brass right here though, this is $600, and that doesn't include that tank tee. That tank tee with the accessories on there was like another $150. So to be honest, this isn't a real practical setup, but we're planning to use this as drinking water and everything, and everything I have here is all lead free. I spent a lot of extra money on down here. We've got a reduced pressure device, a double check valve. It's more than a double check valve, but you know, Wilkins Zern, whatever it is, backflow device here, and we've got one there. When I disconnect from the main city water, I'm going to pull that RP device and move it back to that one. So basically all the irrigation we run will all go through those reduced pressure devices, which I paid extra money for. The all brass lead free construction, those were expensive too. So figure, you know, I could have done this for half the money in galvanized probably, or I could have done it mostly in PVC. But you know, I really want to have the above ground stuff very weather resistant. I don't want to have PVC harden up and crack and cause a leak and be pumping 45 gallons a minute and flood this whole sucker out. So this should be lifetime right here. Pretty darn close to lifetime, if not literally my lifetime. So that's the story of getting it ready while I'm waiting on a 3-month back ordered pump. But looking pretty clean. And I did paint the conduit tan, although I guess I could have left it gray. But sweet setup.